because it's lower. But if I were to need to, for whatever reason, access something on this DMZ or the inside network, I have to pass an access list. I have to by rule. If I don't, traffic will not pass. Okay, that's on that page 150, 151 of your order of operations. Same. DMZ 50, I can get to the outside, I don't need an access list. I can get to this DMZ, I don't need an access list. But if I needed to reach devices on the inside network, I have to pass an access list in order to do it. That's where the security levels come in. Again, just as important as the established rules that we talked about previously. Routing. Okay. Stepping back here. Firewalls do three things at a bare minimum. At a bare minimum. They have to do three things. Okay? They have to route. They act as a router. Okay? Unless they're transparent. Caveat, unless they're transparent. They have to do some sort of inspection between two interfaces. Because they're going to be set at different security levels. Alright? They have to NAT. That's what they're there for. They have to NAT. Alright? Routing is a key piece. Now, in the good old days, we used to just have to set up static routes on firewalls. In small organizations and small networks, you have to maybe set up one default route. That's it. Tell it where to go to if the network is not directly connected to the inside interface and you're only running an inside interface. If you had multiple networks below the firewall, you would have to put static routes to find those off of other routers or layer 3 switches in your environment. Okay? So routing is really easy at the edge. What happens when you have firewalls within an organization that are protecting assets or networks from others within your own organization? They don't touch the internet. This does happen. You see a lot of it in government. Okay? Government IT are some of the most paranoid people on the planet. Rightfully so. So, firewalls have to be able to do dynamic routing protocols such as RIP, EIGRP, OSPF, OSPF-v3 if you're in an IPv6 environment. NAT, the second thing it has to do, is translate, either statically or dynamically. If you're doing a static translation, it's one for one. It works the same way, in the same fashion, and the command structure is darn near identical to what you have in iOS. Okay, that's the good news. Port address translation is a little bit different. Okay? Now you had to make pools and class maps and all kinds of other stuff in iOS to get port address translation to work. Okay, in iOS it's two commands. A global command and a local command. That's it. Global, what am I setting my port address translation to? What's the one IP address I want to set it to? And what's the address ranges that can use that address? That's it. Really simple, really straightforward. NAT control is a way to bypass NAT altogether from an administrative perspective. Okay? Typically, you would only do that between inside and outside, inside and DMZ. If you did that from inside to outside, you're not going to get route out because you're not going to have a public IP as your source address. Your packets are going to get dropped. And finally, access lists. Similar to iOS CLI application. They're written in the same, and they're applied in the same. Okay? There's a maximum of 2 access control lists per interface or per context. Same rule as on a router. Now, since there's only 2 allowed, what does that tell you? Anyone? You can have 1 inbound and 1 outbound. Same exact rule. Modular policy framework. Alright? This is similar to the zones that we talked about last class in the iOS feature set. Gives capability for intrusion prevention system, protocol inspection, quality of service, policing or rate limiting, which is a real cool tool to have, and TCP connection settings. Okay? We don't do a whole lot with MPF in the labs or on the test, but it's a good thing to have if you ever go out and you're doing your own engineering. Cool. So, I'm going to now go over Lab 2. So, here's what I suggest that you do. Not just this lab, or any type of question that you get if you go and get a CCNA, sit for the CCNA exam or CCNP exam. The lab portion, you will have lab portions on those exams if you so desire to take them. Read through the entire lab before you start. Read through the entire lab. So, IP the routers according to the diagram. Ensure you give them their proper host name. So, okay, I got 1, 2, 3 IP networks, 4 IP networks, 3 routers, R1, R2, R3. Good. Create the routing protocol domains according to topology. Ensure you have full 100% connectivity between all routed networks. Consider all networks to be routable from R1's Ethernet interface downward. So I have to see all these networks from R1. Okay, not a problem. Have to do redistribution here. There is the same OSPF domain, autonomous system. Okay, good. Nothing tricky. So 1 redistribution command here. Let's see. Block any routing for RC 1918 to the internet. Okay, so standard access list here, probably on this inbound interface. That's fine. 1918. I know, I goofed. Re-IP. Re-IP your /25 to /29 on all interfaces of that subnet. So, tricky piece here. Instead of re-IPing, why don't I just IP it that way from the start? There's no penalty, right? I just won't duplicate work. Okay, so I'm going to catch number 4 here when I do this. Create NAT. I have to create NAT. So these are these devices here. Can we come back to 5? Create an overload and overload. Create and overload a PAT address tied to your R1 serial interface. So I got to put PAT right here. All right, for what? For what? Allow the workstation subnet to use it. Okay, so that's that now. All right. Have R3 serve up a DHCP pool. We've done that in the past. That's no big deal. 192.168.50.4 is your Active Directory / ACS server with the following credentials. I need to have administrator password, username the administrator, password change me. Okay, have R1, R2, and R3 authenticate to the AD server via ACS. AD or local is okay. Alright. Create an access list. R1 as follows. Remember you used NAT previously. Okay, so wants me to do an ACL here. I have to NAT these devices. So I can do this one of two ways. I can do the NAT here and the ACL here. Or I can do the ACL here and the NAT here. But if I do that, I have to ensure that this router knows where that network, that new network is. So I have to do an additional step in routing. Either way is fine. I'm going to do this the easy way and do the ACL and the NAT right here on R1. Okay? It's a better practice to do it that way because you're closer to, you want to do your ACL, always want to do your ACLs closest to your enemy. Alright? And you want to do the NAT on the same device that you're using an ACL. This is better practice. So I have 1, 2, 3, 4, 5, 6 ACL steps. And then we have our OSPF Area 0 MD5 key. Alright. So, two things I have to do. I have to build a server. Let's see if I have a server built. Hey, I have a server built. Yay. I did do something right. Now the tricky part about this is getting the server on the same network as this router. Here. I'll show you how to do that.
You said you changed this 3. You said you changed this 3.
Were you able to get us the keys for workstation?
What?
Were you able to get the keys for workstation?
You can use VM Player for this lab. It's no big deal. I'll work on that.
Oh, we're not using GNS3 again?
No, you are.
Let's get that stuff.
Oh, I can.
There was a button on this. So let's skip.
Yay! It worked. All right. project. R1. R2. R3. Switch 1. I'm sorry, switch 1, switch 2, switch 3.
Oh, and then connect it.
Switch to.
All right. So, key important thing here is to understand how your VM is going to be set up networking wise. All right. Right now, I am tied to the outside world, which is fine, but I don't want to be. I want to be tied into my inside world. So in order to do that, I need to change my address. And I am 192.168.50.4. All right. So, turn all these guys on. That to happen, and we'll boot up. I'm going to come back here to my settings on my Windows box and look at my adapter settings. Private network shared with the host. Okay, so make this VMnet 2. Okay. And there's a thing in settings where I can actually manipulate my in VM Player, it's within the application. In VM Workstation, you actually have a virtual network editor that you go to. So I just need to change this subnet to 192.168.0.0. Okay. Now if I go to here, if I pull a cloud over, and I right click and I click configure on the cloud, I now need to drop this down and find VM network adapter 2 and attach it to that. Click add. Now, in actuality, I don't need this switch anymore. I can just simply manually connect my fast Ethernet port to this cloud. And just for giggles, I'm going to change the icon to a server.
But we initially have to do the other part first, right? With the server.
You don't have to. No, you can go. You can skip straight to there. All right. Now, open up all of the VMs. And I'm going to start working on R2 here just real quick. I'm going to go into Fast Ethernet 01. I'm sorry, Fast Ethernet 00. And give it IP address 192.168.50.0 or 50.1. Back to my .4. Okay. It goofed somewhere here. I put 00 and not 50.0, I think. Do the show interface. Hey, I see that it's up. Ping myself, and hopefully if I did this right, I can ping the server as well. Okay, so I can ping 50.4, which is my server, my VM. That's a huge step. That is, if you don't get this, you're not going to be able to test everything correctly. You can still do all the steps, but you won't be able to test everything correctly, which is important. So, make sure that in your VM setup You're using host only. Okay. Your cloud, all right, is going to be your VM. You select that proper VM net. All right. And then on your server, your IP is on the same subnet as your router. Then you should be able to do a ping. Okay? And hopefully, if I did everything right, I can ping everything on both sides, which I can't. Huh? I pinged myself and I pinged the router. Okay, so I have full connectivity. From there, I can move on. Again, host only on your network adapter setting of your VM, and you're on the same subnet. Oh, sorry.
In the server, is there anything other than the IP that we have to change?
Sorry, one more time, sir?
In the server,
Yeah.
in the VM, is there anything other than the IP we have to change? No services, nothing like that, right?
I shut off the firewall
Okay.
just so I'm not blocking ICMP. Trust me, that's it. All right, so next I want to make sure that I have all of my routers on there according to the diagram, proper host name, yeah, I did that. And now I want to create everything, but I want to change this, step 4, which is this domain right here. So, I'm going to do this one router at a time. I want to switch back and forth here. 201.68.109.
Stop recording.
And .128 in your subnet mask is a /25. Every time I bring up an interface, I'm going to type no shut. Okay. I also have to do all the routing domains. Windows.